So we have discussed about how to model in ETABS. So previously we have discussed about how to model frame structure and how apply the material for the frame structure and how apply the uh, section properties. So today our lecture is about how to uh, make the meshing of the slab structure or shell structure. Actually, meshing is required to make it the properties of along the section or across the section to identify and to reliable results. So we use meshing. Like just click here. So it will be select one slab panel. So now just I go and change this into all stories. All stories. Now when I clicking here, selecting these panels automatically select all panels on the different stories. Now I want to mesh this slab element. So I just go edit tab and shell edit divide shell. Just click here and here we have different options. So divide quadrant triangle into this and this degree. So divide selected shells, okay, into this degree, and here you have the option. I put here this into that every shell will be divided into 4 cross 4 by 4. Just click OK. So here you have already different small panels. The panel you have divided into smalls. Normally across, if you check the bending moment and shear force, so the result will be very reliable and restrain the results within the supports here. Okay, so now we have done with the meshing of the slab. So next step we will define, and we have the option that we will apply the diaphragm. Okay, diaphragm basically to keep the vertical loads transfer to the transverse load into the the slab loads, intensity loads to the beam and beam to the column. Okay, so diaphragm will form a rigid structure to transfer the loads. Okay, just click here, D1, modify. So diaphragm D1, semi rigid. Okay, rigid is okay. Okay, so here is okay, D1. How you will apply the diaphragm? Here is your previous selection. If you go previous selection, so here you have another way to for selecting the material, the slab. Just go shell slab section, slab 1. Okay, so now you have selected all slab 1. Okay, so you can clear the selection. Select properties, slab section, slab 1, select, close it. Now you have selected all slab structure, so you can go and assign diaphragm. Okay, this diaphragm you have assigned on both roof as well as on the first floor. Here you have, this will show you the point of rigidity of the whole structure. Okay, so one thing we are missing here, that we have not defined the staircase on this roof. For the roof I just make it inaccessible. So I just click on the one story and make the here is option draw, here is slab, make it opening. Okay, you can choose and make selection up to here. I consider it's opening for staircase, so I will use this space and this for the staircase from ground floor to first floor. So I'm okay with the openings. So this is already diaphragm we have defined. Let me select previous selection. This is not meshed. I don't know what's the reason behind this. Let me mesh first this one. Edit, divide shell. Okay. Now this is all we have meshed. Previous selection. So or you can select here uh, all story. Select slab section property. It is a easy way to select the slab property or element of the model. Just select here. You have now selected. Come out and assign shell diaphragm. The diaphragm we have defined in the defining tab. Okay, this from this. So just okay. And now your diaphragm is shown on the this window. So this is okay with the diaphragm. Now I am defining the function, response spectrum function, and also we have the mass source. First let me define the response spectrum function, but before response spectrum function I will define the mass source. Okay, so mass source we have different options. When our live load is some given limit, every code have their own limits, but if it's 3.4 or 3.5, you can use live load is 50%. Let me modify this mass source. Specify pattern, dead load 1, live load 1. But now we did not define the service dead load. So let me first define the service dead load. You should know all these steps because one by one I am sharing all these steps. I'm backing from the step and I will come again this step how we will use. So our dead load pattern is not fully defined here. So let me define the dead load pattern first. Cancel. Define. First you need to load pattern, dead load, service dead load. Service dead load will be hold furniture loads as well as your tile load, floor finishing load, roof finishing load. It depend on these loads. Okay, so I will make it a very simple and you can calculate it very easily. Load application tutorial. So here you can super dead. Okay, this zero mean is that this load will not be calculated by the ETABS. It need to be put your input. Okay, you need to put this super dead load. Dead load and member load is calculating by ETABS itself. So add just add. Here you need to ex earthquake load, construction load, super dead load. Here is seismic load. Just add EY. Just add. Okay. So first you need to here is UBC 97 because my code is about UBC 97. Just modify and here is UBC 97. Modify. Click OK. But here is not the story is finished. Yes, just go and load pattern ex. You need to modify Here you see that all directions and centricity is checked. Now first I am doing for the only no need of a centricity. If you consider okay, if you don't consider, it's also okay. So this is I consider as if I don't know the soil type, soil test data, I consider it's a the little the foundation making possible soil like very low category soil, soil D. If you have the investigation, you can put the soil type here. Okay, soil A, soil type B, soil type C. So I consider soil type. Seismic zone factor. For me now I'm at Dasu, so I will use zone 3. Okay, this will give you CA and CB value. You need to know what's the use of these values here. So you need to put this value in the your response spectrum function. This will be program calculated. Story, first floor, second floor, top, bottom, base, or you can put from ground floor. Okay, not from base. Okay, so this is worst strength factor. There is a table in UBC 97 and also building code of Pakistan. If you have the building code of your country, so you can put worst strength factor. Worst strength factor is depend on the zone, and zone can provide you the moment resisting frame. It may be the uh, special moment resisting frame. It may be ordinary moment resisting frame. It may be intermediate moment resisting frame. For my case, worst strength factor I consider its worst strength factor I consider 8.5. Importance factor 1, if you have some assembly structure like mosque and you have the like other institutes like school, hospital, you consider 20% or 30% as per your code table. So this will be in the code of UBC 97. So I don't want to make the video more length, so I will just guide you that you can get all this, what's important factor and what's strength factor, you can check and you can take from the table. Just click OK, and same you need to do with the y direction. You do uncheck this one, uncheck, and user defined soil type. Their x and y input should be same, must be same. Zone 3, because you cannot for x zone 3 and you cannot do for y zone 4 or some other zones. This will be 36 and 0.54. This you need to put in the second floor, base and ground floor strength factor. Okay, now you have okay with all these definitions. So here you can add one live load already there, so no need to put here one superimposed dead load. You need to add that you can put that wall load. Okay, wall load, just okay. Now you have okay with the loads. Now it's your uniform load case, so you can static, live load, static. Okay, because we are doing for the structure, considering for our model is normally in civil engineering is the static. Okay, so for model analysis we do is the model cases, and we will check the stiffness as well as the drift. Now okay, click here, load combination. So we have as default load combination, concrete design frame. I am doing concrete design frame. Okay, so you are okay with 10 different. If you put your pointer on the tab, it will show you the uh, load combinations here. So okay, so your model will be designed on the base of the maximum demand. Let's suppose some combination have more demand, so the response and induced stresses will be more. So your structure needs some additional reinforcement or some additional size of the member. So to make sure that all combinations should be passed, it will be designed on the maximum demand. So just you go with OK, and then you have to you are defined tab almost you have done, but one point we have missing last time, that we are response spectrum and our mass source. So just mass source 1 is default, you can add also. Modify specific pattern element shell mass, uncheck all these one, add one SDL 1, dead load should be 100%. Okay, here is not a wall load, I think it was not add. So let me add the wall load first. Define load pattern, define wall load, spring load, add new load. Okay, define load case, now you can OK. Define mass source, modify, uncheck, add, dead, add 100%. Live load, in my case I consider 25%. EX and EY no need, EX and EY no need live load, because this is floor loads. EX and EY are not floor, this is induced load after shaking. Okay, so this is OK. Include lateral mass load, include vertical mass load, no vertical no need, story level lateral mass. OK, so now you have defined the mass source, and mass source will show that when after shaking you are building on the floor, what type of behavior and how much the contribution of the mass is there. Like live load is little contribution, dead load is always there, so its contribution will be more, the effect is more. Now you can go and your function, response function. So you need to add new function, you call it response spectrum. Okay, now here you need to put these your data. So but this is add modify spectrum, response spectrum function. Okay, you need to first check here UBC 97, add new spectrum, response spectrum. Okay, so this we have checked that we have already. Let me show you again. So this make sure that define here load pattern EX modify. Here you see 0.36, 0.54. You need to put these values in the CA 0.36 and 0.54 in the response spectrum function. UBC 97. My code is this. Add new the response spectrum CA 0.36, 0.54. Okay, this is our response spectrum based on this model. So you can check again. Okay, CA 0.36, make sure that CA 0.36, CA 0.36. Now it's okay with your model. This is program calculator, you need to put this into spectrum. So this is all about the definition of the load patterns, load case, response spectrum, mass source. So this is all about the definition of the load input. In next video we will learn about the